Thank you for the introduction. First of all, I apologize if this presentation might be a bit rough. Normally I'm used to more IT kind of audience, so I had to fit it a bit for this kind of architectural biennale. MX3D is a company that crystallize what most of the conceptual thinker that has been on this stage before present as a project. We have seen in other presentation other sorts of digital fabrication kind of companies operate from now in the background, but now I will show you a bit what's on the other side. So how one of those company has been founded or how it works. We come from the design world, unlike many other of such companies that have been founded in the university world. We come from the JAROSLAV lab. It's a design studio that has been open, I think, around 7 years now. And the main interest and the main focus is to challenge the production in especially the digital fabrication methods. So what is that that can be designed that really push the boundaries of a specific kind of technique? Here we see a few chairs that has been assembled by producing a lot of blocks with a 2.5D milling machine, like a common milling machine, and then a lot of human work to assemble everything together, a lot of glue. At the same time, one of the first projects was this the bone chair, and it's one of the first application on an everyday object of what is now a very common type of analysis that mimics, in this case, the growth of bones of a human body. So yeah, FEM analysis kind of machine. What's interesting is that 3D printing here has been used not for the production of the chair, but for the production of the mold, and the aluminum has been die-casted afterwards. At the same time, we also works a lot with robots. This is very, very sci-fi. It's a sort of coating developed by NASA at the beginning, and it's a tungsten carbide. It's one of the hardest material can be used. And yeah, this table can't be scratched, even if you really try. But all of this knowledge eventually arrived to one of the latest product you 3D printed with some of the latest powder bed laser. Unfortunately, the video is not playing. But it's, I will show you immediately the project. Yeah. It's a gradient chair. It's all made with aluminum, SLS machines on a powder bed. And the process was almost as slow as the video that hasn't even started. It really took a lot of time to produce this small chair. It's really small, like it's this big. And but it has this really complicated generative sort of design that adds more material where the stress it's gonna be more, and keep it lighter in the spaces where it's not necessary. But the downside was that to produce such a small chair, we had to break it down in many parts to fit the printing volumes of the machine, and it was expensive. I think a small like this, one of those small chair, it's just to produce it is half the price of an apartment of a reasonable size, so not really everyday use kind of product. And so at a certain point we said we would like to create our own technology, because it's really complicated to deal with those companies. It's really expensive, it's really slow. Plus the imprinting of the lab has always been of sort of a do-it-yourself kind of thing. We always tried to do everything in the studio by ourselves, and already outsourcing those kind of things was a bit hard for the philosophy of the company. So we said, let's develop something. And since we had already some robotic experience with the coating of the table, we said, yeah, let's try to use robots. They have a lot of freedom, and it was also a period. It was around 4 years ago. It was a period where robotics fabrication was really booming, so we had to jump on the train ourselves. And yeah, that's where we developed, maybe some of you already seen this video, we developed this freeform 3D printer that doesn't operate on layers, and that was a bit the difference with the most common kind of 3D printers back at the time. Plus, there was no gravity issues. So you can see here it's printing horizontally and without any problem. The only thing was that the material was terrible. Like it would disintegrate just by looking at it. It was suitable for nothing, and I guess except doing nice viral videos. And yeah, which is good. I mean, viral videos are an important side of the internet. So we said, let's continue this project, because there is a certain degree of value in those kind of shapes and in this kind of freedom. What is the thing that could help to make it better? Definitely a better material. So we did some research, and of course, like for furniture production, we worked a lot with metal, and then we said it would be nice to be able to use some sort of metal alloy to extrude from these robots. So we had the answer in the workshop. It was a welding machine. So we decided to connect the welding machine on a robot, just like a very ordinary welding robot. It's used in the production of cars on a daily basis. And yeah, and that sounds, and to produce like sort of medium scale, like furniture scale size objects, using welding as a additive method rather than a joining technique. And that sounded really, really amazing and innovative, except, yeah, we found the patent from 1925. So yeah, it was done, which is a positive thing. It means that someone already tried it, tested it, and it would work. If it would work in 1925, let's imagine what it could do in 2013 on a robot. Like the only reason probably why this patent was never led to anything except the mug, and what I really don't understand what it is that it was manually done. Like some artists actually performed some project with this technique, and it was really, really interesting kind of things. But yeah, on our side, we decided to do the leap, and yeah, and mount it on the robot, and you can see that it's pretty much doing similar things as the project before, but with a material that is actually useful for something. So we started developing a software, we started developing printing strategies, so meaning how the metal is to be deposited, how the CAD file has to be splitted, develop printing heads, different printing techniques, welding programs for printing horizontally, upside down, vertically, any sort of free-form shape that you could think of. Especially at the beginning, we were focusing on lines, like free lines printing. And this led to our first project, that is a Dragon Bench. It's quite large. This one, if I remember correctly, is around 2 by 3 meters and 1.5 meters of height, with this beautiful, quite simple, I have to say, like yeah, reticulate sort of structure. And yeah, once we, it was printed in parts, of course. Like we had a very small robot at the time. It was indeed impossible to print such a huge volume in one go. So it was printed in many parts and then welded together afterwards, made with stainless steel. And anyway, some coating is always good, because yeah, you never know how the material behaves after it has been heated up so many times, so often. But this project was a bit of a game changer, because once we've seen how good the material was, how good the property were, how stable the chair, the bench was, we realized that we couldn't confine this technique only on the applied art kind of market, but there were good reasons to start a startup. Like, it's really fancy to say startup now, like a company that had really low budget and really high goals. So we inaugurated our robotic field lab in 2014. Yeah, in summer 2014. It's in a huge creative hub in Amsterdam. Yeah, of course. I mean, you need to make viral videos, as I said before. Like, people need to see this. We need to. We especially at the time we need to have sponsors or companies that would believe our idea was interesting enough to to give us some money or knowledge or robots or whatever. So we created we built our robotic lab. Much bigger space. Before it was a room filled with people and metal gas, which is very bad. And with bigger places comes also bigger ideas. So this is again a little picture of how it used to look like, our place. Very, very professional, robot cages, safety systems. It's unbelievable compared to what we had before. So yeah, we actually can walk around without risking our own life. And we developed a few projects together with JAROSLAV, which is, of course, one of the founder of the company. So we still work for the applied art market, which is really interesting because it's a great push for shape development, for freedom of shapes. We did also some low engineering products like a bike with some students in the TU of Delft, and some reticulate kind of structure just for testing how large printing would behave, or how large, in general, like large line meshes would react when loaded and something like that. Plus, we are also very active in the industrial market, but the industrial market is also really secret. Projects are mostly under disclosure kind of agreement, so I cannot show much. But this process has really a lot of application that goes beyond like art or little bikes and stuff like that. But we are here to talk about architecture. So what can MX3D offer to architects, or in general to the architectural world? We have three main things that we are working on, and so it's print large, print smart, and allow freedom of forms. There's also a fourth one which doesn't really fit in a slide, and that's material quality, but that's not aesthetically pleasing to put in a slide, so I left it out. Large. How do we print large? This picture shows both the mess that we have now, but shows the three ways we use to print large parts. So the first one is large hardwares. Robots can be very small, but also quite large. So whatever fits in their range can be printed with our system. I think the largest robot we have is the largest model of ABB, and it allows prints that goes from on a line of 4 meters horizontal in front of the robot for a height that goes around, I think, 2.5, 3 meters. Then there is indeed a design for assembly. Like, it's not a shame to assemble something afterwards. First of all, it employs people, and second of all, it helps to go larger, where the hardware can't reach, human indeed can. And the third one, which is the more under development one, and also interesting, is to have hardware that can move over the structure that you are building, which indeed mean that your structure has to be strong enough to hold also the hardware that is creating the tool. This is one example of a large part that we printed. It's a sort of a panel facade, kind of a screen thing. It's also all made in stainless steel. It's around 2 meters high and 2 meters wide. I think a bit more, 2.5 meters wide. It has a microstructure inside, so it's also optimized in a way that it's not full, it's not a full solid, it's not just a shell, but it's a bit like cardboard. It has a sort of undulated part that helps to keep everything steady and stiff, because it's of course really heavy. We continued with some sort of just tests for the sake of testing shapes. Whatever come to our mind, we would try to elaborate it with our software and suddenly print it with the machine. So we have from vases to lattice-like structure, springy structure, pipe subdivisions that were mostly kind of studies for overhangs and that kind of stuff. Fading from solid to a shell to a mesh kind of shape, to see the different properties that those kind of things can have, or more like organic and artistic shape. The first very large project that we made is this bar. It's for the new Museum of Modern Art in Miami. I think it's called the Cocoon Bar. It's also all made of stainless steel because it has to stand outside. It had some interesting rules that we had to respect. So it has to be hurricane proof because it's in Miami. So the structure has to be strong. It has to support itself, but it also has to be. It doesn't have to act like a wing when the wind is too strong. And it has been built in a few parts and manually assembled afterwards. But it was pretty much a very good success to display for the first time to a third party, to a customer, how and what we can actually do. But then afterwards, we started thinking, we are a startup, we are pretty anonymous, and we need to make something to show what's our potential to the world. Something that acts on the city. We are in Amsterdam, which is really touristic kind of city, so there will be a lot of public. And Amsterdam is also the city of canals, so we said, why not a bridge? Why not a bridge? We talked with the city of Amsterdam. They were very enthusiastic about the idea. So we started testing immediately on small scale, just to see, prototyping a little bit, have a feeling of how the technology would react to such a kind of project. Of course, we are only a team of programmers and a few engineers, but we definitely have no architects or civil engineers. So that was a really challenging kind of project. This is an idea of what we were thinking of. So the bridge would be in the center of Amsterdam and self-assembled by the robot that moves on the bridge on location, building the structure while moving forward. That sounds really innovative, but of course it has been done as well. I mean, it hasn't been done, but that's how many bridges were built. This is also from the 20s, a great era, I guess. And that's how I think it's the Sydney Harbour Bridge, built in 1925. And it's incredible, right? It's a bit like a digital versus analog kind of thing. I always love these images. It's amazing how some, everything goes around in a way or another. And as I said before, we are not, we have no architects, we are no civil engineers, we are no mechanical engineers. So I'm not showing this slide because I need to show the partners that we have, but I want to show how many parties needs to be involved on such a large project in order to make it happen. Like so many knowledge that has to come together to allow something that, it's a bridge. There are billions of bridges, but the way this one has been done, it's so innovative that really a lot of minds has to come together. And one example that I normally give is that it's really hard for tools like for analytics tools now to perform structural calculation on the shapes that we want to print, because we also want to display the fact that we can create very special shapes. But the softwares are not ready to accept those shapes and calculate the load, for instance, of the shape. So one of our partners used to be a Dutch contractors company, one of the main. They used to build roads, viaduct, everything. And we started to work with them. We were forwarding them some design and everything, and they were saying, "No, I'm sorry, like our machine, like our software cannot calculate that. Can you make the pipes a bit more round? Can you make your knots a bit less organic, a bit more like a truss?" No, we can't, because we don't want to build a bridge that looks like any other bridge, but it's done with a 3D printer. So we want to make something both to showcase the technique, but also to showcase the freedom of the process itself. So eventually we came across Arab. They have brilliant civil engineers. They were really amazed by the project, and that's where we found like sort of synergy that we were looking for. And so we started many iterations of the bridge with the most sophisticated software. Autodesk is also a partner, and that really helps a lot. And eventually we decided to follow the stress lines of just like a sort of a placeholder. In order, here you can see the cross connect, the beams being built, in order to to minimize the risk. Like it's quite of a challenge. We don't want to take any risk. It's still a bridge where people has to walk on, so we don't want an accident. Like we just want to make a nice and useful bridge. Here again, so everything has been built. First of all, we made a sort of a placeholder that the rough shape, like a sort of a bent surface, lean it on the canal walls, and calculated what would be the stress on such a simple shape. Once we individuated the stress line, we decided to use them as a guide for the main elements of the bridge that has to, in the end, stand all the forces that it would go through. It's a pedestrian bridge. It's not for cars, of course. We're not that crazy. This is like a quick shot, a render of how the look is. So we've seen before the running pipes underneath, and on top, of course, there will be a plane with one of those anti-slip sort of materials, and so the bottom part is all functional, and the handrails are purely decorative. It's purely to showcase the freedom of forming that this process has to offer with with metal materials. This is the stage now. So we could not build it on location because the city couldn't calculate the risk associated to such manufacturing method. So they're very conservative, and in a way they're very right, because the center of Amsterdam, it's very touristic, and specifically this bridge would be in the red light district, which is overcrowded any time of the year, and it's hard to calculate the risk factor for such a project. Drunk people trying to walk over the bridge, robots flashing lights. It was a bit too much. So that's why we also got this location. It has a lot of space. We built our fake canal walls, and we started the print. And this video was made a couple of months ago. And despite what we're seeing now, here is a proof of concept. We could not, for budget reasons, and also because this project got a bit on our way of the rest of our missions, we decided to mostly print it in blocks and then assemble it afterwards. But to prove that the concept of the bridge moving along the bridge, the robot, sorry, moving along the bridge is still a valid concept, and we developed the technology for that. We decided to showcase this project. Every Friday we are open. We have a visitor center where people can come and see the bridge being built. And so in a way it was a bit of a letdown, but in another way it really sped up the process itself. Like we printed the first 2 meters in around a month and a half, and now that the process it's well developed, so we know which steps are necessary. We are already almost done with all printing, and the main problem is that the city of Amsterdam is not done yet with fixing the canal walls. So this lack of synchronization with the bridge manufacturing and the city fixing the canal led to a possibility of a very interesting project that is going to be called IoT, because it's based on the Internet of Things, and it means that the bridge itself is going to turn on into a living laboratory, and that's how we are going to prove that this bridge can actually be open for the public. It's really hard to calculate, as I said before, like how it's going to behave, what's going to be the internal stresses, because it's something that is welded, so it's heated constantly and then cooled down constantly, so there are a lot of internal forces. And so how can we make sure that no one is going to get killed on this bridge. We are going to fill it with many experts, of course, with sensors from, they go from load sensors or also just like flow measurement sensor to see where the people is going, how many people are on the bridge at that moment, what's the load on specific parts of the bridge, and if it's cracking somewhere, if it's rusting somewhere, all those kind of things. And it will be live. It will be on a website. That's at least the concept, so that university can learn about this project. It's really important for us, that students get familiar to this new technology, because that's how you start using something. It's mostly thanks to students that decide to adopt it in their project for the future. So yeah, this is how we'll try to create a sort of virtual model of the bridge, constantly updated, day by day, minute after minute, showing the flow, the stress, everything. And the first part will be done at our location, so while we wait for the canal to be fixed, we will load the bridge, test the sensor, test the resistance, test the elongation, stress, everything. And what we have then for the future, this is very conceptual kind of ideas, but what we're working on at the moment is a system to move accurately the robot around. We actually have a project going on with some students from the TU Delft now, in the next weeks, that will lead to another very viral video, I hope, to show the system that we developed to move the robot, recalibrate it, understand his surroundings and everything. And but what are we going to do with it? It's mostly what the market wants. So when we get concepts that are interesting enough, or concepts that like sounds like they have been thought for this technology, because sometimes you just get concepts that, just people that say, oh, that's cool technology, let's do that thing that I made like 5 years ago with that. It doesn't fit at all. Like everything, like when you do something for milling, you are designing it for milling. And the same is when you're doing something for metal additive manufacturing, it has to be designed for metal additive manufacturing. So we have many partners or many other companies involved, and we are now teaching them how to use our technology. So is with the help of the external world, so from industrial company, propeller manufacturing, casting companies, but also building companies that we tune our software, we tune our tools, and we make them ready for the future and ready for whoever wants to use them. So this was it. Hope I've been quick enough. I know there has been a delay. Thank you very much.
Thank you, Filippo. Question from the publicum. When is the day that we can walk through the bridge?
When is the day? Yeah, as soon as the city is done fixing the canal, and that's a lot of bureaucracy.
And in your laboratory?
In our laboratory.
I might often visits to Amsterdam, so I would like to come.
I think around the end of the year, unless we need to reserve robots for more, for other kind of project with tighter deadlines. But I would say January, February, it's ready to the public.
Okay, cool. So please, January, February, you can come to Amsterdam. Now we will have a half-hour coffee.